Okay, so we will proceed in vector, summation, and integral calculus. Okay, so we are in discussion for the vector, summation, and integral calculus. Vector, summation, and integral calculus. Can I solve a problem by dividing into n number of parts, then sum the parts? Can I divide problem into n different parts? And then part by part you solve it, and then you sum it. Okay, and then after that you make the summation n tends to infinity. I believe it is all right. If I have a problem, then divide problem into n different parts. Each part can be solved using vector. Okay, the idea was to use vector, but right now we are not using it. But idea is that if I have a big problem, can I divide my problem into n different parts? Each part I have to solve it by vector. Okay, after solving each part, then I have to add all the n part. After adding all the n part, if we feel that it is not the perfect solution, then we will make n division n tends to infinity. If I'm adding so many parts, n parts or n tends to infinity, then it can be, not necessarily it will be exact solution, but it can be brought up into integral calculus. So that is the concept that we are pursuing, mind blowing, amazing. In that fashion, we have done calculation of the, we are in a kind of a bank interest loan and those kind of concept that we are pursuing. What we have solved till now, we took one example, like if I need to solve a problem that is 5 plus 5 plus 5 plus 5 plus 5 plus 5, 5 into 7 times. Okay, can we solve this problem through integral calculus? Okay, 5 plus 5 plus 5, 7 times. It is same as 5 into 7. It is same as 5 into 7. This is called repeated summation. If I have repeated summation, I can call it as a multiplication. I believe everyone understands this. 5 plus 5, if I say 7 times, it is as good as 5 into 7. So any repeated addition can be brought up into multiplication. Any multiplication can be brought up into integral calculus. Any multiplication. 5 into 7 can be rewritten as 5 into x. 5 can be rewritten as 5 into x to the power 0 into x. Now the first part, 5 into x to the power 0, is function over x, and next part is x. If I have multiplication of function over x multiplied by x, it can be rewritten as fx dx, and limit is 0 to 7. If it is if you are adding 1 1 1 1 means 5 5 5 5 7 times, I can have a limit that will go 0 to 7, not 1 to 7, the way people expect. It will go 1 to 7. If I set 1 to 7, fx is 5 into x to the power 0 dx. 5 is constant, x to the power 0 will become, integration will be x to the power 1 by 1. 5 into x, x is 0 to 7, 5 into 7 minus 5 into 0, 5 into 7. Any repeated addition can be brought up into multiplication, and then any multiplication can be brought up into integral calculus. We did more towards it. Consider that I am trying to calculate 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Makes sense? Earlier we did 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5. Now I am doing 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Okay. Can I bring it into multiplication? Not possible. Bringing 1 plus 2, 7. It is not possible to bring into multiplication. How someone can write two multiplication of two items? If I multiply two items, it cannot become 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Not possible. Okay, then how it will be possible? Yeah, it is possible. If I write it as x plus x plus x plus x plus x plus x 7 times, what do you mean? This is what is called repeated addition. So instead of 1 plus 2, I say 1 is x. 1 is x. Or I can say 0 plus x, where x is varying. But altogether, if I write down, it looks like same. X plus x plus x plus x plus x plus x plus x. Like that. It looks same. If it looks the same, then it is x. What is the multiplication then? X 7 times. X into 7. This is what we are doing, where x is varying. Okay, if I go with integral calculus, then it will come as x into x. X will be fx. And 7 I can write as dx or x, any x. First is x, another is x. Make sense? Okay. So it will become x into x, or right side x will become dx, because right side is independent component. That would vary. We have fixed x. How many times? X times. X into x, where right hand side x is independent component and left hand side x is dependent component. That is how calculus identifies any algebra, dependent and independent. So x into x looks like, if it is independent, it will become dx. X into dx. X square by 2 is the net integration. From x, if I say from x, that is going 0 to 7, the way we did 0 to 7, the net addition will be 7 square by 2. If it is not, then it will be near to it. Someone can try. 7 square by 2, 49 by 2, 24.5. It will become 24.5. Someone can try. 1 plus 2 plus 3 plus 4 will be 10, plus 5 15, plus 6 plus 6, okay, plus 6, then it will be 21, plus 7 will be 28. So I looks like it is similar. Okay. If I up to 10, then it is 10 square by 2, 100 by 2, 50. Let's try here. Here the error is coming as 3.5. Okay. If I try more than 8, 28 plus 8, 36, plus 9, 45, plus 10, 55. Now error is 5. So this is how it is. So it is near to it. Okay. So this is the way we can turn anything into calculus. Then we were doing the banking problem. What is banking problem? Banking problem is saying that a person has opened a fixed deposit amount, fixed deposit account, and in fixed deposit account he has deposited y0 money at the time 0, at the time equal to 0. He has deposited y amount of money in the bank. Now he is expecting C as interest rate. Every year C interest rate he will get. If bank employee, they have told him you will get 8%, then at the end of 1 year he will get whatever y0 amount is plus y0 into 8 by 100, or y0 and in bracket 1 plus 8 by 100, or y0 in bracket 1 plus 0.8. 1 plus C is also we can write as A. I believe it is understandable. And everyone in 9th class or 10th class, people would have read about it. Okay, if someone is depositing Y0 money in the account and he is getting C as the interest, annual interest, that is recurring interest, compound interest. He is getting compound interest. After every year, principal plus interest amount will become principal only. And then again C% interest on the principal amount. After T year, the money Y0 will become Y0 and in bracket 1 plus C bracket close to the power T. If I say 1 plus C is A, if I rename, because 1 is constant plus C is constant. 1 plus C, if I say A, then after A year, Y0 will become A to the power T. Makes sense? Y0 will become A to the power T. Okay. Now someone is depositing. Now we are saying in this, as we have talked that whatever we are talking, everything in mathematics, we will prove it through electronic circuit. Okay, I have one small Okay, I have one small electron. I don't know where that went. Okay, this is just, oh, so much dirt is there. Like this is a typical electronic circuit where we have two capacitors. Other things were there. Now two capacitor is shown, but backside there are many ICs are there and resistors are also there. So this is like backside and front side. We have two capacitors are there on the front side. So this is the electronic circuit. Whatever we are talking in calculus, everything we will implement on electronic circuit and we will run and we will show. The concept is that we don't have oscilloscope and idea is to write a software for the oscilloscope through the any microcontroller so that we can have at least in megahertz scenario we will have an oscilloscope in the megahertz frequency, not probably in the gigahertz, because if processor speed of the microcontroller is in 1 gigahertz or 2 gigahertz, then probably be divide by 100. It would be possible divide by 100. That will come if it is 2 gigahertz processor. If I take, then around 20 megahertz signal I can show as a as a wave. So that I will try. Okay. So please support us. This is what I always say. Please support us because it will be enthusiastic to see all the mathematical computation. It will be enthusiastic to see all the mathematical computation through the electronic circuit, Fourier transformation to anything. If someone is seeing through electronic circuit and he is seeing output in a oscilloscope, the way the calculus is working different, say, please watch our previous video also. So that will be exciting. So that is for sure. Anyways, the concept is arising that if I have a fixed deposit amount and if I have deposited Y0 money and A equal to 1 plus C, where C is the interest rate, then after end of T year, Y0 will become Y0 into A to the power T. What about if someone is depositing S0 S money, S amount of money in the account every year? Okay, means Y0, like consider this is a person deposited Y0 money in the account at the beginning. This is a span of 1 year. At the end of 1 year, someone is depositing S amount in the account. So at the end of 1 year, the net amount in the account is Y0 into A plus S. Now this is second year. If this is second year, after second year, the money will become Y0 into A plus S. That is the principal amount here, whole multiplied by A. And then someone is depositing S amount again. S amount is being deposited every year. So at the end of 2 years, the amount in the amount in the fixed deposit is Y0 into A plus S bracket close into A, okay, into A plus the S amount someone has deposited. So at the end of 2 years, so it will become Y0 A square plus S into A plus S. Okay, at the end of T year, it will become Y0 into A to the power T plus S A to the power T minus 1 year less, because the first S that were deposited at the end of 1 year. So S is seeing first S amount that is deposited in the fixed deposit from outside. It will go number of span of the year less than 1 year, that is Y0. Then it will become Y0 A to the power T plus S A to the power T minus 1 plus S A to the power T minus 2 plus S A to the power T minus 3, like that up to S, or altogether it will be Y0 A to the power T plus S, and in bracket A to the power T minus 1 plus A to the power T minus 2 plus A to the power T minus 3 plus A to the power 1 plus A to the power 0. Okay, this part and then this part. This is the whole equation. Y amount in the fixed deposit at any T after any T year equal to Y0. Money deposited at T equal to 0, Y0 into A. That is the first amount someone deposited in the fixed deposit into a to the power t after t year plus s. S is the amount, external amount that is being deposited in the account at the end of every year in bracket a to the power t minus 1 plus a to the power t minus 2 like that up to a to the power 1 plus a to the power 0. Now question is arising, if it is not understandable, that understand this much, this has to be understood, that if I have a summation a to the power t minus 1, a to the power t minus 2, a to the power t minus 3 up to a to the power 0, what can I compute this summation through integral calculus? Can I compute this summation through integral calculus? Then we will have now this is the net summation a to the power t minus 1 plus a to the power t minus 2 plus. This whole summation I can break into t different parts. T different parts. First part is a to the power t minus 1. Second is a to the power t minus 2, t part. Last is a to the power t minus t. Okay, so altogether we have t parts. Okay, we have t parts. If we have t parts or n parts, then can I go with the repeated addition so that I can transform into integral multiplication, and then multiplication will get transformed into integral calculus. What is repeated summation? If I say first is a to the power t minus x, second is a to the power t minus x, like that all are a to the power t minus x, then it is repeated summation. Then I can rewrite as a to the power t minus x into x for x term, a to the power t minus x dx, where x will go from 0 to x will go from 0 to t, the way we were doing in the earlier equation also. It will go 0 to t. If I had to add 5 into 7 times, then integration will go 0 to 7. Here I have to add t times, then integration will go 0 to t. Okay, now try a to the power t minus x, integration will come as a to the power t minus x log a outside minus. A to the power t minus x integration will be a to the power t minus x by log of a. Okay, outside minus will be there. Now set x as 0 to t. If someone set x as t, it will become a to the power 0, that is 1. And if someone sets 0, a to the power t, 1 minus a to the power t minus is outside a to the power t minus 1 by logarithmic of a. Okay, where a is 1 plus c. Okay, c is the yearly interest. Every year how much interest he is getting. If I say every year if I divide into n different parts, this is possible. This is 1 year span, and many banks they provide monthly compound interest, not yearly compound interest. One bank is providing 8% of yearly compound interest. If you go to another bank, he will say, I will give you 8 by 12. 8 by 12, that will come as 2 by 3. 2 by 3% monthly interest. Then you will say it is same as 8% yearly interest. Yeah, it is 8% yearly interest. But we are giving monthly compounding. Means whatever you have principal amount at the beginning, principal amount into in bracket 1 plus 8 by 12 into 1 by 100, means 8 by 12% interest I'll give you every month. So after end of 1 month, principal amount will change as per principal amount into 1 plus 8 by 12%. Then principal amount will get updated every month. So at the end of 1 year, you will get more than 8%. In that fashion, this 1 year I divide into n different parts. If I divide into n different parts, then whatever we have now, the summation what we have calculated, it is a to the power t minus 1 divided by logarithmic of a. This is what we have calculated now. Logarithmic of a becomes 1 plus c by n, where n times we are dividing a year. Okay, then it becomes logarithmic of 1 plus c by n. On top we have a to the power t. T will become n into t. N into t means if we have t years, it will be multiplied by n. N number of slots will be there now rather than t number of slots. A to the power nt, where t is in year, n is how many times we divide 1 year. 1 year if I divide 12 times, monthly basis, then n will be 12. A to the power nt minus 1 by logarithmic of a, that is 1 plus c by n. If n tends to infinity, if I chop even more per day basis, per second basis, or something like that, then logarithmic of 1 plus c by n, where n tends to infinity, or logarithmic of 1 plus x, where x tends to 0, it will become x. Log of 1 plus x, where x tends to 0, it will become x1, because log of 1 is 0. So it will become c by n. On top of it, a to the power tn minus 1. So it is by tn minus 1 by c by n. If someone try a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 plus 1 through algebraic way, he will get a to the power t minus 1 divided by a minus 1. A minus 1 is c by n minus 1. But this way, we use integral calculus to compute the fundamental, it is workable only when we have in a form of a as 1 plus 1 by n. If a is written as 1 plus 1 by n, where n tends to infinity, then only it will match. Is there any other way to compute it? Okay, we have talked about it. What is other way to compute, to convert our repeated addition to integral calculus? Repeated addition cannot be written as integral calculus directly, not possible. Repeated addition cannot be written as a cannot be written directly as integral calculus. It is not possible. Why it is not possible? Is integral calculus computes the area. The problem of the integral calculus is it computes the area, whereas repeated addition is repeat. If this is x-axis and this is considered that this is 0 and this is 1, and then I have n number of verticals. If I add all the vertical, add all the vertical, will it be same as if I take the top of the vertical as a graph? Makes sense? Consider y equal to x. Y equal to x square. Consider y equal to x square. Okay, if it is y equal to x square, this is the graph that we are getting. What is the area between 0 and 1? Y equal to x square. Then x square integration will be x to the power 3 by 3. 0 to 1, the area will be 1 by 3. Makes sense? Consider I take three verticals. One vertical is at 1 by 3, another vertical is at 2 by 3, and last vertical is at 1. Okay, now add all three. At 1 it is 1, at 2 by 3 it is 4 by 9 x square, and at 1 by 3 it is 1 by 9. So 1 by 9 plus 4 by 9 plus 1, that is 9 by 9. If someone adds it, then it will become 1 plus 4, 5 plus 9, 14. 14 by 9. That is far more than the actual area. That is that is that is 1 by 3. If someone calculate the area between x equal to 0 and x equal to 1, if this is the area, x equal to 1, if this is the area, then that is 1 by 3. But if I take 3 vertical also in between, and if I add all 3 vertical, then it will be 14 by 9, that is much higher than 1 by 3. So if I have a repeated addition of vertical between 0 and 1, I cannot say it is integral calculus. If I have repeated addition of x square, if I have repeated addition of 1 by 9 plus 4 by 9 plus 9 by 9, then I will say it is like x square. Yeah, it is x square. Then I can write as x square dx, and x is from, that will not work. Repeated addition of the vertical will not resolve into integral calculus. This is what we are saying. We can compute any summation through repeated addition, that we have seen. If I have to compute a to the power t minus 1, a to the power t minus 2, a to the power t minus 3, then I can say this is a repeated addition of a to the power t minus x, where x will vary, but as a whole it looks like all are same now, a to the power t minus x. A to the power t minus x, x time will be written as a to the power t minus x into x, or into dx, where x will go from 0 to t. If I do like so, it works. provided a is in form of 1 plus 1 by n where n tends to infinity, or 1 plus x where x tends to 0. In that fashion, the actual summation a to the power t minus 1 plus a to the power t minus 2 plus a to the power 0, that is the actual summation, and that is actually a to the power t minus 1 by a minus 1. Anyone computes a to the power t minus 1 plus a to the power t minus 2 up to plus 1. This computation would resolve into a to the power t come down minus 1 by a minus 1. If I convert it into repeated summation, if I convert into repeated summation, then it will resolve in a to the power t minus 1 by logarithmic of a. Loosely, I can prove that it is same as a to the power t minus 1 by a minus 1, provided a equal to 1 by c, 1 plus c by n, where n tends to infinity. That we say, is there any another way? Can I bring any summation into form of integral calculus? Then we can solve the problem. Okay, any tedious problem. If I take same thing a to the power t minus 1 plus a to the power t minus 2 a to the power t minus 3, if I am trying to solve through integral calculus, then we have same thing a to the power t minus 1. If I say this is x-axis, if I say this is x-axis, then this is x equal to 1, 2, 3, 4, 5, 6, 7, 8, whatsoever. And then this is these are the vertical bar. If these are the vertical bar, then I have a function called fx which is sampled at some location. If I add or, I get what I want. Can I convert this fx into integral calculus? Means, can I convert this fx into another function called gx, so that gx dx integration from lower limit to higher limit will give the actual summation. Summation, that is capital S, summation S equal to a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 plus a to the power 1 plus a to the power 0. If I sum it through algebra, it will become a to the power t come down minus 1 by a minus 1. But question is, can I solve it through integral calculus? We saw it. We did it, and it came as a to the power t minus 1 by logarithmic of a. Okay, certainly that is not perfect. It is perfect if a equal to c, if actually a equal to c 1 plus c. If c tends to 0, then it is false. Is there any other way to calculate it? Other way is, if I say, if I have a vertical bar a to the power t minus 1, a to the power t minus 2, a to the power t minus 2, 3, like that, if I connect all the top of this vertical bar, it will resolve into a curve. That is, if I call it fx, then it is summation I equal to 1 to t, and then a to the power t minus I. This is what it is. Can I write this summation I equal to 1 to t a to the power t minus I equal to integration of some other function dx, where x will go from lower limit to higher limit? Is it possible? If it is possible, if I am able to find gx, then I can get the same summation through integration also. Okay, the concept is to find gx. What is fx? Fx is a to the power t minus x. This is fx. So fx equal to integration gx dx. Make sense? This means that gx dx equal to fx. Dx equal to dfx by dx. Okay, so we can start like this. Then what is gx? What is fx? Fx equal to a to the power t minus x. If I differentiate with x, it will become minus. It will become minus log a to the power t minus x. Now we know what is our gx. Let's try. Now instead of gx, I write now minus logarithmic of a to the power t minus x dx. Now summation. What I'll sum now? If I take fx function at any x, I have a vertical. Any x, I have a vertical. This vertical will become area in terms of integration. Means if, okay, if this is fx, If this is fx, if this is x-axis and this is x equal to 1, this is x equal to x. If this is x equal to x, then it will go up here, and this full height is fx. Okay, this height should be equivalent to, if I have another function as gx. This is another function gx, and gx, if I say gx dx, that is, it is giving me the area. If I take any x and x plus 1, if I calculate this area should be exactly same if I take fx, and then that is the height at x. Makes sense? If they match each other, the fx is the single height called point mass function, and gx is a density function. Gx from x to x plus 1, whatever the area strip I am seeing, that area strip should match the fx point mass height. Both are same, then we get it. Okay, so now fx at x equal to x is a to the power t minus x, where gx we have calculated as minus log a e to the power t minus a to the power t minus x. If I do the integration of it, it will become minus 1 by log a. Minus minus will go. A to the power t minus x dx integration will be a to the power t minus x divided by minus log a. Both will cut each other, and integration will be e to the power t minus x from x to x plus 1. If someone compute it, then a to the power t minus x, instead of x it will be x plus 1, e to the power a to the power t minus x minus 1 minus a to the power t minus x. Okay, someone can take a to the power t minus x as coefficient. Okay, then in bracket it will come as a to the power minus 1 minus 1. Make sense? A to the power t minus x is the integration net. Then that limit I have to set x to x plus 1. X plus 1, if it comes, then it will be a to the power t minus x minus 1 minus, then x will come here, a to the power t minus x. If someone do that, a to the power t minus x, someone can take out, and in bracket what will remain is a to the power minus 1 minus 1. Okay, that is extra. What is left side? Left side is a to the power t minus x. Right side is a to the power t minus x, and in bracket a to the power minus 1, and come down minus 1. This is extra. That I have to divide now, because this is the extra we are getting that I should not get. Now we will try again. Minus log a by a to the power minus 1 minus 1. And then someone has to do the integration from x to x plus 1. Certainly it will come as e to the power t minus x, and in bracket a to the power minus 1 minus 1 by minus logarithmic of a. Everything will go away, e to the power t minus x will remain, and both are same. Means we have found that gx is gx is gx is minus log a by a to the power minus 1 minus 1 minus logarithmic of a log base e by, and then a to the power minus 1 come down, and then minus 1. This is what extra we have got outside, and then gx is a to the power t minus x. Now we have to integrate it. A to the power t minus x, if I integrate a to the power t minus x, now x will go from where to where? X will go, if I take x will go from 1 to t. If I take like x will go 1 to t, then how much it will be? If x goes 1 to t, then how much it will be? In earlier case, we had taken 0 to t. Here we'll take 1 to 2. A to the power t minus x. If I do the if t a to the power t minus x, if I do the integration, first of all, integration will come a to the power t minus x by minus log of a. Minus log of a and minus log of a both will go away. Only a to the power minus 1 by minus 1 will remain in the denominator. Numerator will be a to the power t minus x. Now that is x is 1 to t. A to the power t minus 1 minus a to the power 0 minus 1. A to the power t minus 1 minus 1. Makes sense? Now we have a to the power minus 1 in the denominator. A to the power minus 1 is 1 by a. 1 by a. It will become 1 minus a by a. A can go up now. A would go up. Okay. If A goes up, then it is a by 1 minus a by 1 minus a. Okay, and this side we have taken a 0 to t. Okay, 1 to t. If I put t, then it is, if I put t in a to the power t minus x as t, it is 1. It is 1, and 1 minus a to the power t minus 1 is coming. If I multiply both side by my if I both side by my minus, then they will switch the side. So top will become a, and in bracket a to the power t minus 1 minus 1 by a minus 1. A into a to the power t minus 1 minus 1 by a minus 1. Okay, if I have to compute a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 up to a, not plus 1, the end last is plus 1, up to a only. If I have to compute like that up to a, if someone is trying through algebra, what is computation of a to the power t minus 1 plus a to the power t minus 2 plus 8 plus a to the power 1? If someone compute this, how much it will be? If I say this summation is equal to s, then let's multiply s with the a. Then it will become a to the power t minus 1 up to a square. If I subtract it, then it will become s a minus 1 equal to a to the power t minus a square minus a will remain a to the power t minus a. Okay, a to the power t minus a, if I take out a, then it becomes a into a to the power t minus 1 minus 1 by a minus 1. Both are same. If I don't take a, it is manageable now. This is what I am trying to say. Now we have come to more or less same solution. Someone would get by the repeated addition if it goes through algebra. We can compute through integral. More work is required here. But it is amazing. In past session, in the last previous day, we calculated that summation of x number 1 plus 2 plus 3 plus 4 up to x. Through this methodology, it results in x into x minus 1 by 2. If people remember it, x into x minus 2. It came as their gx came as x minus 1 by 2. X minus 1 by 2. Like here gx is minus log a by a to the power minus 1, come down minus 1, e to the power t minus x. This is the gx we are getting. If I am trying to calculate 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, then it is gx is coming as x minus 1 by 2. If I integrate x square by 2 minus 1 by 2, x 1 by 2 I can keep outside, x square minus x. This is what we are getting. X into x minus x square minus x means x into x minus 1 by 2. It is very near to the actual summation in x into x plus 1 by 2. Only thing I have to replace x with x plus 1. Similarly, here we are getting a into a to the power t minus 1 minus 1 divided by a minus 1. It is very near to if I add a plus a square plus a, not with the 1. 1, if I leave the first one, then it is coming exactly like this. Means little bit more tweaking is required. Anyway, this is called achieving any discrete summation through the approximation integration. This is not available in any of the book. Through approximate through the through approximation in the integration. We are doing approximation only, step by step. We are coming closer to each other. What is the in discrete manner? What is the height at any point? That height should become area in integral calculus, sub area. Sub area from x to x plus 1. This is what we tried, and we got a into bracket a to the power t minus 1 by a minus 1. This is exactly same as if I compute a to the power t minus 1 plus a to the power t minus 2 up to a to the power 1. Same thing we are getting. Plus 1 is missing. So someone has to do little more work in it and it will come. Okay. If this comes to a fixed calculation, if this methodology what we have started, if it comes to a fixed calculation, then this is a big invention. Big invention in the sense any tedious summation, generally people see very tedious summation, and that is impossible to summate, then someone can, if that equation is called fx, then we can have equivalent gx through which integration will work, and that will be far easy. We don't mind supporting us. Plus 91 is the India country code 9483160610 is the telephone. Plus 91 is the India country code 9483160610 is the telephone number. Amazing mind hitting in the wall.